group. Let's MCing and MCing. Tejas Kumar, y'all. Hello, how we doing? Oh my gosh, you all are in 3 dimensions, and I'm in 3 dimensions, and we're not on a Zoom call, and it's so amazing. I'm so happy to be here with all of you. My name is Anjana Vakil. I am a developer based in San Francisco, and I have come all of this way to talk to you about JavaScript generators. Woo! The slides for this talk, including some code examples you can play around with, are on observablehq.com/@Anjana, so you can play around with it there. Because, yeah, I want to spend the next half hour talking to y'all about this really hot new feature from like 6 years ago. Generators and their companions, iterators, which go hand in hand, we'll talk about in a second. They're not new. They're not the fresh hotness in JavaScript, but even though they joined the JavaScript party way back in ES6, I feel like we don't talk about them enough. They've been here this whole time, and we haven't really been enjoying them as much as we should be. I think that generators are super underappreciated. I know there's at least one person in the audience who agrees with me. And woo! 2 people! And I am hoping to try and amend that a little bit today. So we're going to talk about some things, some hopefully you agree cool things that generators can do. I feel so short. I can't see y'all. Hi. Some cool things that generators can do, and also I think it's not just that they're actually useful, like you can do practical things with generators. Sure, there's always multiple ways to do things in JavaScript, but generators make working with things like sequences, even doing stuff like async iteration, a lot more comfortable in JavaScript, I think, so they're actually practically useful. But also, I love generators because I think that they're also amazing teachers. If you don't have a computer science background, like I do not, you might have some gaps in your knowledge of like kind of underlying computer science concepts, things like control flow, things like systems programming, how processes talk to each other, all that kind of stuff. And it turns out that generators, once you start like reading them up and DuckDuckGoing them and digging into the rabbit hole, you might find that it leads you to a lot of really interesting understanding of some underlying computer science concepts. So I think they're not only useful friends to have in our little toolbox, but also great teachers that we can learn from. And once you start following some of those rabbit holes, I think you might find they can actually do some pretty mind-blowing stuff. So that's what I'm hoping we're going to at least scratch the surface of today. So before we get into all of the mind-blowing things that generators can do, let's talk about some basics. So what is a generator? Well, a generator is a type of iterator. Okay, cool. What's an iterator? So as I said, iterators and generators kind of go hand in hand. And an iterator, of which a generator is one, an iterator is just a thing that has a next method, which returns objects of a certain shape. So any object that has a next method is an iterator if that next method returns little objects with a value property, which might have some useful value, a number, a string, another object, whatever. And then a done property, which is a Boolean, which indicates whether iteration is over or not. So when you call the next method on some iterator, you'll get out a little object that maybe has a value, like something, very useful, and also has a done property, which in this case is going to say done false, meaning I still have more iteration to give. So you call the next method again, and maybe this time you get another thing, same shape of object, but a new value. The done property is still false. Keep going, call next again, and eventually you might get to an object where perhaps you don't have a value, and the done value is true, because that means now we're done with iteration here. So iterators and generators are a type of iterator, are useful for doing iteration. You're going to hear me say the word iterate like 8,000 times today, so prepare. A few more terminology things while we're getting naming collisions and confused about the names of things. Let's talk about generator functions versus generator objects. So the function star keyword, you've seen it? You've seen it around. It's like function. It has a star on it. That makes it fancy. It means this is a generator function. And you all also notice generator functions by the fact that they often have a yield keyword, because that's what makes them useful. So a generator function, which is defined with function star and has yield in it, When we call it, it gives us back a generator object, which has that next method. So that's the iterator. So we can call the next method on that generator object and get out values. Now that yield keyword is what's going to put those values in the value property of the objects returned by the next method. So here I have a very simple one that just yields one value, hello world. When I call next, I get that value, done is false. And what has happened is basically the code is running until here. I yield out that value, hello world. Then when I call next again, the code continues running from where it picked off up at the where it left off, picking up at the yield statement. And since there's nothing else left in my function, it's just basically returning undefined, the last value is undefined, and the done value is true. Now we're done running this function body. Okay, so generator functions return generator objects. And as we just saw, but let's look at a little bit here to see example, the next method, when I call that, it advances through the function body of my generator function until it hits a yield. So here I've got a fun generator function I'm calling logerator, which when I instantiate it, I get a little logger object, a little generator object. When I call next on that, JavaScript starts running the code at the beginning of the function body. So I get console log running, I see running, then it hits the yield, and it pauses. And it returns, or it spits out the value after the yield, in this case paused, as the value of that object returned by the next method. But when I call next again, as we said, it picks up where it left off. So it starts running right after that yield, which means it's going to log out that running again. And then in this case, it could maybe have hit another yield or paused again. But in this case, it hits a return, or maybe the end of the function. In this case, we can return a value as well, instead of just returning undefined. So that value stopped is going to come out in the final call to next, along with the done true telling us we're done with iteration. With me so far? Cool. Woo! Yay! All right. Y'all are amazing. Okay. So fun thing about generators is they're not just iterators, they're also iterables. We're going to get so confused by the time this is over. And I know I'm talking super fast. Thank you, everyone, for putting up with my super rapid English. We have a lot of cool things to show about generators, so I'm rushing. Okay. So generators are also iterable. So here I have a little kind of boring little generator function, ABCs. It's going to successively yield letters in the alphabet ABC. The fact that generators are not just they're not just iterators, they're also iterables, means that I can use them in for-of loops, or I can use them with the spread operator, same as I could use an array, which is another example of an iterable in JavaScript. So here, if I instantiate my ABCs, I call that function to get my generator object, I can use that in a for-of loop to get out each letter. So in this case, I'm getting each letter, making it uppercase, and logging it out. And I can use them anywhere that iterable objects can be used, including our handy-dandy spread operator. So I can spread the generator object into an array and get an array with all of the values that are yielded out. Cool? So you might be like, why would I ever do that? I could just make an array with A and B and C in it. Why would I write a generator for that? Well, okay, for a small, finite sequence of letters, you probably wouldn't. But what's cool about generators being iterables is that they make it really easy to write more complex iterable objects. So let's take a look now that we've seen how generators work, let's take a look at what they can actually do for us. All right, so one really cool thing, I hope folks can see this at the back, but one really cool thing that you can do with that generators make it very easy to do, is to create custom iterable objects. So we said that any object that implements the next method can be an iterator. Since generators give us iterators, right? Since generator functions give us iterators, we can also hook them up to this cool property called symbol.iterator, or the @iterator method. And the way JavaScript works, since all this came down in ES6, is that anytime I try to iterate over an object with a spread operator or a for-of loop or what have you, it's going to look to see, does this object implement this symbol iterator method. And what I can do is assign the value of symbol iterator to any iterator. And in this case, a function star is a great way to create a new iterator because generators are iterators. So this makes it really easy, I think, to create objects that are whatever we want them to be, that we can iterate over simply. So here, for example, imagine I'm a very lazy programmer, and I need an object that represents a deck of cards, but I don't want to sit out and enumerate all 52 different card values. So what I've got here is a tiny little object, just a regular object. Ignore the parens around that curly braces, whatever. I've got the suits enumerated, and I've got maybe the court cards enumerated. I don't need to enumerate the numbers 2 through 10 because I can just count from I. So what I've got is a little anonymous generator function, which is essentially going through and computing all the permutations of the different suits, the numbers 2 through 10, and the different court cards, and it's successively yielding those out one by one in traditional dealing order. So what happens then is when I iterate over my card deck object, just a regular object, keys, values, properties, values, I get as if I had just written an array with all of the values. They're all there, I promise you. All 52 things are in my card deck, even though I didn't have to sit down and write those all out. So for more complex or longer or even infinite sequences, the fact that generators help us do lazy evaluation like this is really useful. Okay, so that means we can actually do iteration over infinity and beyond. So what I've got here, I'll let you take a look while I take a sip. Water! Let's give it up for water. Yeah. Man, I hope we still have it in 20 years. All right. So what I've got here is a little generator called Infinity and Beyond, which has something which, if you're like me, might strike fear into your heart. A while true. The thing is, this while true has a yield statement inside of it. And remember, yield pauses. Generators are kind of like pausable functions, so I no longer have to fear the while true, because this won't run infinitely unless something is infinitely pulling from it by calling the next method. So we can actually do while true and not break our entire computer. Yay! So what I've got here is an infinite sequence, which is only going to be evaluated as I request things from it, so lazy evaluation. I've got another little generator that's kind of inspired by some functional programming languages often have a lot of lazy sequences, lazily evaluated sequences like this. And you'll sometimes find a little utility helper called take, which allows you to take the first n items from that sequence. So take here is just a little, also a generator, which is going to take as many items as I tell it to from a particular iterable. And so what I can do is take 5 things from infinity, just borrow a little bit from infinity. And since take is also a generator, I can spread, that returns a generator, I can spread the result of that into an array and get an actual workable array from a potentially infinite sequence. Now this is very simple, I'm just giving you numbers, but you could also imagine we're lazily evaluating, doing some expensive computation to get each of these numbers that I don't want to do for a million different things all at once. I only want to do it when I actually need them. That means I can also do stuff like infinite map. So I have a little map generator here, which similarly takes in some iterable and is going to take some other function that I want to map over that iterable and lazily map it. So that means I could actually map over infinity. Huh? So what I've got here is a little map, a call to my map generator that's taking this infinite sequence and mapping a little function that takes a square of each number. So now I have an infinite sequence of squares using my infinite map, and I can use my little take helper to, let's say, get the first 9 things out of that. So these are really simple examples, but hopefully you can see that with the power of a lazy evaluation that pausing each time that we call next gives us, we can actually create really expensive computations, infinite sequences, things that would otherwise crash our computers. We can work with them just as if they were arrays in JavaScript. Or whatever other iterable. So I think that's pretty cool. I don't know about you. The other thing that since we can pull infinitely from generators, we can do really cool things, like, for example, power animation. Did you notice these weird little, hopefully no one is disturbed by the little spinny text animations here. Credit to Mike Bostock for that animation. This is an animation that's powered by generators thanks to the observable notebook runtime. So if you haven't checked out Observable, it's a pretty cool environment. It works in a functional reactive style. So you have little chunks, cells of JavaScript code, which are evaluated reactively. And the runtime, what it does is anytime it sees a generator, indicated by the yield statement, it pulls from the next method of that generator once an animation frame. So what that means is you can have like an infinite generator, like here, this is one that's built into the observable environment called now, which just keeps yielding the current time, the date.now value. And observable pulls from that once an animation frame, so 60-ish times a second. And what that means is then I can use that value in other things, like, for example, a little SVG, which is using a kind of sine wave based on that timestamp to animate this text, animate the SVG using some utilities there. So again, you can check out all this code online. But this is just an example. This is probably not the most common use case, but using these infinite sequences, you can do really cool things when you start thinking that you have control over when to pull values out of it. So runtimes like this are heavy users of generators. The other cool thing is that we have also a yield star operator. Have folks seen this, encountered this, seen this? So yield star, what it does is it works similar to yield, but with an iterable. So if I yield star from an array, let's say, what it's going to do is the generator is going to pretend that it had like yield the first element, yield the second element, yield the third element. It's going to successively yield elements from that iterable. So what I have here is an example of how this can power recursive iteration thanks to symbol iterator and yield star. All right, I have a very simple little data structure here, a binary tree, where the nodes are just teeny little objects. What they have is a value, some number, some string, whatever, and they have that symbol iterator implemented. And that symbol iterator, the value of that is this generator function, which is representing depth-first tree traversal over this binary tree. So we're going to go down a branch and then pop up and then go down the next branch, as opposed to breadth first. And what this is doing is it starts out, we yield the value of this node, and then if the node has children, we use yield star to successively yield the entire subtree represented by that child node. So what we get then is if we hook up a bunch of these binary tree nodes into a tree structure, and this is just a very simple one, it's got a couple branches, a couple leaves, all made up of these same binary tree nodes. That means that when I hit yield star on another tree node, it's going to recursively enter the symbol iterator property. So it's going to recursively hit this same generator on each of the child nodes to give me this depth-first tree traversal that I just wrote in this one little, tiny little data structure. So what I have here now, I've got my little tree object, which is essentially represented by the root node. I can spread that tree. I can do a for of with that tree, and I get out all the values in all of its parts using my depth-first traversal. I could also swap out my depth-first function and do a breadth-first one and use that instead. So this makes it really nice to implement recursive data structures like this that you can then work with as if they were arrays, right? I can just like do a for of over my tree. Try to do that without generators, and it will make you pull your hair out. So this is a fun thing that you might find one day you actually do want to use at work. Or you might just want to play with it and make silly little trees like this. Both valid. All right. So these are some cool things that generators can do, and we haven't even started talking about async yet. So in ES6, we got the magic of generators and iterators. In ES7, we got the async versions of both. So that means we can start doing all of the stuff that I just said asynchronously as well. So in addition to function star, we can now do async function star to get an async generator function, which we can use await in. Okay, question. Have folks heard of the Star Wars API, Swappy? Anybody used it in examples? It's really fun. It's a public API that just has a bunch of information about the Star Wars universe. So for example, you can get all of the characters in the universe, or all of the planets, or all of the starships, or what have you. And each of these is at a different endpoint, but because there are a lot of things in the Star Wars universe, those results are paginated. So what I have here, and credit to Luciano Mamina for this example, is a little async generator function, which what it does is it is loading that paginated data page after page until it's done. So what we've got is a little value next URL, which is taking in, so this is just a little helper function. I've got get swappy pagerator is a little helper function, which I'll give it an endpoint that I'm interested in, and it'll give me back the async generator function that I need. So what I've got here is a little next URL, which starts out with just the base URL. And then as I enter a while loop, what I'm going to be doing is fetching fetching the results from that URL, parsing it as JSON. In that data that I get back, I'm going to have a next URL, which is telling me what the following page is for more results. So I'm going to replace the value of my next URL, and then I'm going to use my friend yield star to take the results array, which has all of the objects that I'm interested in on this page, and successively yield them, one after the other, using yield star. Cool? So what this means is with my little get swappy pagerator, I'm getting the appropriate async async generator function for each of these different endpoints that I'm interested in. I can now create a little object that represents the Star Wars API. So I can have properties on that object, like a characters property, which itself is an object which all it does is implement symbol async iterator. And what that does, and I have the same for a couple other endpoints, what that does is it tells JavaScript, I can use this in a for await of loop. So just like for of or the spread operator, when I use it in JavaScript, JavaScript goes and looks, hey, is there something at symbol.iterator for this object? Because then I can use it in the for of. Similarly, we now have for await of, which is looking for symbol async iterator. And so if I implement that, I can use my little objects here in this for await of loop to pretend that this asynchronously loading paginated data is coming in as if it was just an array that I could loop over. Okay? That's pretty cool, right? So what we've got here, thank you to the Star Wars API and Luciano. So what I've got here, and you'll notice, so again, let's combine this with the fun thing in Observable where it's going to show me the results each time there's an animation frame or each time new data is available. What I have here is now, it looks like just an array of the ships, but if the internet's working, let's see. We can also see how this could work with, let's say, the characters. So once I run this, what it's going to be doing, and here I'm yielding things just because I'm in Observable. I'm yielding this out so it'll show up in my screen, but you could also check the console and see that we're logging these out as they come in as well. So once I run this code, let's see what happens. Fingers crossed. So first page, second page, more pages, so on and so forth. You can see it coming in as it does. Like, how cool is that? It's as if it was an array. Generators! Okay. All right, so I've lost control. All right. So what we've seen is a bunch of ways that generators can be really useful to produce series of data. All right, so what we have is we have sequences, we have async sequences coming in. Generators work really nicely as data producers. But it gets even cooler because they can also consume data. What? Just chew on that for a second. Water. Okay, so yield, it turns out, and this is an even less appreciated fact, I think, than just generators in general. Yield is actually a two-way street. yield doesn't just give us out those values in the next method, it also receives values from the next method. So yield can actually function as just like an expression, like pretending it's a value in our function body. So here I have a very simple listener generator function, which when I instantiate my L object, my generator object, when I first call next, this is going to advance until the first yield, right? But notice that this yield now is on the right-hand side of an assignment. What? So you can actually pass in input to the next method, and the generator will grab that as the value of the yield where it was paused. What? So what happens is the first time that I run, it gets to this yield, and so far it hasn't listened to anything. So if I pass in a value on the first call to next, the generator can't hear it yet because it's at the beginning of its function body. It hasn't gotten to a yield yet, right? We said next advances to the next yield. So when I call it, I'm going to hear, OK, I'm listening. Then when I call next again with some value, the generator actually got that. It's going to tell me, I heard, how about now? And then so on and so forth, because we're in a while true, which again is fine for like something that we want to be infinitely listening. So this is actually really weird, I think, and really cool and really powerful, because what that means is that since generators remember where they were, they can also function as state machines. We can use them to represent state. Right? So, for example, here I have a little generator function that represents a bank account. I start out with some balance. Let's say it's 0. I mean, if I wanted to, I could put like 8 million in there, but it's just integers, so not a lot of value. Anyway, so what I have is a little loop that is just checking to make sure that my balance doesn't drop below 0. And as long as my balance isn't below 0, it's going to take in transactions, as it were, the values I pass into the next method, and it's going to add or subtract those from my balance. But as soon as I hit 0, it's going to break that loop. It's going to tell me that I'm bankrupt and return and stop, like, lock me out of my bank account. I'm no longer able to use this. It's over. It's done. All right, so here, just a little example. I start out, I instantiate my account. I call the next method the first time. I have nothing in there, but we're running. I deposit 50. The value is 50. Then I withdraw 10. It remembered that the balance was 50 because we're in the loop of the function body. It's just paused, and it subtracted that 10, so now I have 40. And then if I try to withdraw 60, it kicks me out because I'm bankrupt. But like, it's just a function, and it remembers where it was because it's not a function, it's a generator function. So what happened here is the generator, by pausing at that yield, and by the fact that it can then resume using that value as like an expression in the function body, generators can yield control and get it back. So the generator can say, hey, I'm paused. You just tell me when you want me to start running again. And then when I call next again, it starts running again. So that means generators can yield control, regain control, yield control, etc., which means they can function as this cool thing called coroutines. So now we're getting into the computer science rabbit holes. Coroutines we can think of as sort of little processes that pass control back and forth to each other to cooperate to execute the program. And I'll leave you with some resources, because I'm running low on time. I'll leave you with some resources to read more about this, because this is going to be a lot. Brace yourselves. But what this means is we can do something kind of like actor model programming. Have folks heard of the actor model, or like Erlang is sort of the environment language, et cetera, most associated with this? It's a really cool, I would call it paradigm of computing, where you have your program is made up of small little entities that we could call actors, or here I'm calling them players, which send messages back and forth to each other in order to execute the program. And so then you can have some that are, let's say, in a more like a supervisory role that kind of manage the others, and you can have some that are kind of independently talking to each other. One can die, and the others can keep working. And so it's a very cool model for programming. Go DuckDuckGo it later. All right, so what we have here is a very simple of this kind of actor-style message passing using just generators. A little stage setting, since it's actors, we have to set the stage. So my actors are my players here. I'm just going to keep track of in a little object so that each player has a name. And then I'm going to have a message queue where all of the messages that they're passing to each other go into this queue, and then I can send them out to the respective players as needed. So this little send function essentially pushes a message onto the queue, and then this run function, what it does is it just keeps looking for the next thing in the queue and calling the next method on the player that that message is for, the actor that that message is for, passing in the content of the message. Okay? With me so far? Ish. Okay. So what I have now is two actors that are going to play the knock-knock joke game. All right? So I have a knocker who's going to be passing messages like knock-knock, and I have an asker who's going to be passing messages like who's there in response to the knocks from the knocker. So what I have in these two kind of companion generator functions is essentially a kind of symmetrical, like one yields to the other then is expecting the message, picks up from its yield statement, and so on and so forth, so they can talk to each other. Cool? All right, so what we have now, if I instantiate my knocker and my asker, and then I send them each, remember we need to call next the first time before they can listen, so I send them each a message to just get ready, and then I hit run, then what happens if I log this code out, and you can try this at home, the knocker goes knock knock, and the asker goes, who's there? Gene. Gene who? Generator. Yeah, the sounds in English don't really work out, but you get it. All right. So my last, I think I'm just about out of time, but the last thing I want to leave you with is that this means generators can even outsmart their own environment. Generators can help us outsmart JavaScript, which is one of my hobbies, is escaping recursion limits. So I don't know if folks have heard of tail call optimization. That's another way you can escape some of the recursion limits in JavaScript. I have another talk about that. But you might have seen in your travelings in JavaScript land, you might have seen things like call stack size exceeded, too much recursion, stack overflow. So this happens, among other things, when we do too much or too deep or infinite recursion. And that can happen not just when I have a recursive function that calls itself, but also when I have two functions that call each other infinitely. What we have is an example of mutual recursion. So neither of these functions is recursive on its own, but together they keep going ping pong, ping pong, ping pong, adding numbers to the number that of pings that they've done forever, and eventually I'll hit the stack overflow, too much recursion, what have you, error. But remember how our actor model let us make little actors that talk to each other? So we can actually do a ping pong version using generators, which will keep going forever, thanks to this little actor model, mini actor model environment that we've implemented. So here, instead of my knocker and my asker, I just have a ping and a pong, which are just sending increasingly higher numbers back to each other. And when I run this, after initializing them, I just start things off by sending the first ping with 0. And be careful if you want to run this. Make sure nothing else valuable is happening on your computer at the time. But what will happen is it'll just keep going until my browser explodes. Like, it can actually escape the JavaScript stack size limit. So I don't know, but this is, again, a hobby of mine, is trying to trick JavaScript into doing things it really doesn't want to do. And generators can do that for us. So yay. Thanks, generators. Thanks, actor model. Woo! OK. Sorry that we're a couple minutes over, but to sum up, the practical uses that we've seen for generators, they can help us implement our own custom iterable data structures. Those could be lazy evaluated, those could be infinite, those could be even recursive, like we saw before. We can use generators to remember state, so we can treat them like state machines. We can do data processing with them. We can even kind of power streams with data. I mean, that async data loading is kind of hint at the fact that streams are coming down, hopefully. We're going to have easier ways of working with streams. They're in proposals, and that is all based on this kind of async iteration that we've seen. And we saw some cool computer science concepts. So we talked about control flow, about coroutines, passing information back and forth, and essentially doing co-op multitasking. We talked about the actor model. You can even use generators to learn about functional programming things like the M word, monads. So I'm going to leave you all with some resources. The slides all have the links online, but there's a great talk from back in the ES6 day by Bodil Stoke about the miracle of generators. And there's some excellent resources on generators in Python as well, which Python has had generators since, the dawn of time, as far as I know, and we can learn a lot from that community too. So lots of great resources out there. You can find them all in my slides on Observable. Sorry to have run over, but I just had to tell you about generators. Thank you all so much. Thank you, JSConf, for having me.
That's amazing. That's really good.